couple of them you may be familiar with, but and a couple of them you may never have heard before. Okay, we have what's called a skew line. Okay, parallel lines are in the same plane. So think of parallel lines as being on the same piece of paper. So two lines on the same piece of paper that never intersect are parallel. Skew lines are lines that are not on the same piece of paper. So I could have a plane here, and I can have a plane up here, and I can have one line going this way and one line going that way. And they would never intersect, but they're not parallel because they're like, parallel lines would be like this. Skew lines are kind of like that. They don't intersect, but the only reason they don't intersect is because they're not in the same plane. If we put them in the same plane on the same piece of paper, they would intersect. Does that make sense? Okay, and then parallel planes are planes that do not intersect. So they're like two pieces of paper floating out in space, like railroad tracks, but paper. They don't ever touch each other. Okay, and then we have a transversal. If I have two lines anywhere in a plane, and they don't have to necessarily be parallel or anything, just any two lines in a plane, and some other line comes along and intersects both of them, this is a transversal. Okay, so any line that intersects two or more lines, it could intersect three lines. I could have one line coming like this, I could have another line going over here like this, another one coming there, and I could have one line that comes through and intersects them all, and that would be a transversal. So basically it's just a line that intersects two or more other lines. So skew lines are lines that are not parallel because they're not in the same plane. Parallel lines have to be on the same piece of paper. Skew lines are like on two different pieces of paper. So they don't intersect, but they're not parallel because they're on two different pieces of paper. And if you were to like put the pieces of paper together and make it one, they'd probably intersect. Does that make sense? So they're floating off in space, and that's the only reason they don't intersect is because they're here and here. So it's similar to parallel in that they don't intersect, but they're not parallel because they'll have different slopes. Because they're not on the same piece of paper, it makes them skew. Now, when you have lines and a transversal, it makes angles, and you get some angle relationships. Actually, let me pause this. Okay, so when we have the two lines with the transversals, we get special relationships with the angles. Because if we look here, I have two lines, just any old two lines, and then I have this transversal that comes in. And as you can see, I make 1, 2, 3, 4, 5, 6, 7, 8 angles around the connections. So I'm just going to go ahead and number them. Poorly, I guess. Okay, so I have 8 angles. The alternate interior angles are the angles that are between the two lines. That's why interior. So I'm going to label that. This is interior. Okay, this area in here. Alternate interior means on opposite sides of the transversal. So we get one set of alternate interior that are these green ones, and then we get another set. That doesn't show very well. Let's do pink. Another set that are these pink ones. Okay. And they're called alternate because they're on opposite sides of the transversal. So you get one pair on opposite sides here and one pair on opposite sides there, and they're alternate interior because they're between the lines.
So like 3 and 6?
Yeah, so 3 and 6 are one set of alternate interior, and 4 and 5 are the other set of alternate interior. Okay. Yeah, we're about to do that right now. So we have, yeah, exterior. So here we have the same setup, you know, the same 2 lines in a transversal, any 2 lines in a transversal. The exterior is out here. So on the outside of the 2 lines. And so we have 2 sets of alternate exterior. We have 1 and 8. That makes 1 set. And then 2 and 7 make the other set. Again, on opposite sides of the transversal. Then again, we have, you know, a couple more relationships. We have same setup, 2 lines in a transversal. And these are lines, so they go on forever and ever and ever. Okay, we have same side interior, which are 2 angles that are on the same side. So 3 and 5 is 1 set of same side interior, and 4 and 6 would be the other set. Again, this being the interior, and then same side. These are also known as consecutive interior because they're on the same side. So if you were to count this way, you'd go 1, 2, 3. The numbers don't really matter. It's the placement that matters. So same side interior. And then we have corresponding. So if I have my 2 lines in a transversal, if we look at this and we kind of draw like a little box around it. Do you guys remember that game Foursquare? Yeah. So this kind of looks like a 4-square set, and this looks like another 4-square set if you think about it. Corresponding angles are in the same square. So 1 and 5 are corresponding because they're in the same position in the 4-square. Does that make sense? If you look at each of these as a separate square, 1 and 5 are in the same spot.
So would it be like 2 and 6?
2 and 6 would be another set. 3 and 7 is another set, and purple. 4 and 8. So basically, corresponding just means they're in the same position between the 2 sets. Here we have what's called a rectangular prism. A rectangular prism is a fancy geometric term for box. Okay. Opposite sides are opposite. They're not the same plane, right? Each face of a prism is a plane. Skew lines are lines that don't intersect, that are not in the same plane. Okay, so if we look at this box, the first line I want to take into consideration is FE. That would be this side right here. Okay, if we're looking at FE, EA is out, FD is out, and DA is out. These intersect, and this is in the same plane because this top is one plane that FE is touching. Then when you look at this side, this back side, that would be here if this line is FE. These 2 are out because they're also touching, and GH is out because it's in the same plane. Every line that's not in the same plane, that's not touching FE, is skew. HB does not touch FE. It's not in the same plane. GC, DC, AB, and CB. Do you see that? Like none of these lines that I highlighted blue touch FE, and none of them are in the same plane because FE is like the connection between these two planes, the top and the back. Yeah, all the planes are technically connected in a prism like that. Okay, so FE is skew to all of these lines. Okay, that doesn't mean that these lines are skewed to each other though. Because if you look at this, obviously DC touches CB, they're not skew. So it's only FE is skew to all of these individually. Does that make sense? So you could say you could write them out separately. FE is skew to GC, FE is skew to CB, FE is skew to HB, but why write all that when you can just say FE is skew to all of these? Okay. So we took care of FE.
So like whatever's just not touching.
Whatever's not touching and is not in the same planes.
Can you like make a note of that on the side?
Yeah. Mm-hmm. So let's look at the next one. Let's look at EA. Okay. Right. If we look at EA, well, all of the other lines on the top of the box are out because they're in the same plane. All of the other lines on the back of the box are out because they're in the same plane. That leaves us with these lines here that are not in the same plane and they're not touching EA. So EA is skew to FG, GH, GC.
Why wouldn't FD work?
FD is in the same plane. It's on the top of the box. Yeah. So FD is parallel because it's in the same plane. CD and CB or BC. So if you look at the box, if this is the line we're taking into consideration over here, and we're looking for all the skew lines, they're all over here. Do you see that? And the same thing is happening here. If this is the line that we're taking into consideration here, the skew lines are all over here on the opposite side of the box. And it's going to always be, if it's any other shape other than a box, you're still going to have that scenario where the skew lines are going to come over on the opposite side somewhere. You're not going to ever have a skew line on the same side because those will either be on the same plane or they'll intersect. Okay, so that helps kind of tell you where you should start looking is over here. Okay. You want to try one more?
Sure.
Okay. Let's do, wrong pen. Let's do GH. Why don't you guys try to see if you can name the skew lines, and then I'll put up the answer and we can compare. Lines we have, again, we'll start with FE. Remember the planes that FE are connected to is the top of the box here and the back of the box here. Parallel lines have to be on the same plane and they don't intersect. So FE is parallel to, okay, well, on this top plane, the only line that doesn't intersect it is DA. And on this back piece, the only line that doesn't intersect is GH. So parallel to DA and GH. And that's because they're all on the same side. So with skew, you're looking for the ones that are not touching the same side, and for parallel, you're looking for the ones that are touching the same side. Another set. I'm going to erase. All right, let's look at, we haven't done HB. We'll do HB. Oh, this symbol right here, for anybody that's new, that means parallel. Just two parallel lines. Okay, so if we're talking about HB, the two planes that HB touches are this bottom of the box and the back of the box. And the lines that are not intersecting HB that are on the bottom or the back are EA and GC. So again, if we have our box, and this is the line we're thinking about, this is HB right here, we need our parallel lines to be on one of these two sides. So here and here. Skew, S-K-E-W. Strangely enough, to identify. Yeah, it's basically a sandwich on the opposite sides of the box. So if you take a box and you put your hand like this, those are your parallel planes. So these two, these two, these two. Planes are named with 4 letters. In this case, when you're talking about a box, you can name a plane with 3 letters, but we're going to name it with 4 letters because we're, all 4 corners of the boxes. So there's not a nice symbol for planes. You have to actually write the word plane. F-E-D-A, that's the top, and we could put those in any order, it doesn't matter, is parallel to plane G-H-B-C. So that's the top and the bottom of the box. Like that. Oh, plane, not plan. Sorry. And then if we take the front and the back of the box, we did the top and the bottom, so now we'll do the front and the back. Plane FDGC is parallel to plane EAHB. And then finally we have the 2 ends. So FGHE is parallel to plane CDAB. Not every prism will give you multiple parallel planes. For example, if I had a triangular prism, which is basically a triangle on the side, like it makes a triangle, the sides make a triangle with flat top and bottom. The top and bottom are going to be parallel, but none of the sides will be because the 3 sides will all intersect.
Can you highlight one of those last ones right
Yeah. So we did FGHE, that plane, parallel to that plane. That would be this one. So basically, you sandwich the box. If you can sandwich like this, those are parallel planes. What? Stop it. Remember the angles? Okay, alternate interior angles on opposite sides between the two lines. So we have two sets of those. We have 2 and 8 and 3 and 5. Okay. And then alternate exterior. Oops. On the outside of the two lines. So we have 1 and 7 and 4 and 6. So far okay? Now, this is rotated sideways from what I was showing you before. How do you know which is which? When you only have two lines and a one line, the one line is the transversal and the two lines are the lines you're looking at in between as being inside and on the opposite sides as being exterior. Okay. I'm going to have to erase this, so if anybody's taking pictures of the color, sorry. Corresponding are in the same position. So I have 1 and 5, 2 and 6, 4 and 8, and 3 and 7. Okay. Those are okay? And then finally, we have same side interior, which gives me 2 and 5, and 3 and 8. So, if I look at interior, again, that's in between. Here's 4. What angle goes with it? 6. No, just 6. So 4 and 6 is one pair.
3 and 5. Yeah, 5.
Perfect.
And 8 and 2.
We're doing interior.
Oh,
Yeah, just in the interior.
JK. China. Do you want pictures of this too? Nah. Just take it.
Okay, so those are the two pair of alternate interior angles. So far okay?